All right, we're going to try a little recording here. This is a factoring problem. We're going to look at something like 8x cubed minus 12x squared plus 10x. And we're going to try to factor using the GCF, which is just the first of many factoring techniques we're going to study this semester. When you look at the GCF, what you want to do is you want to look at each of these three terms here and try to figure out what divides evenly into both of them. Now, when you look at the terms, you want to look at the numbers, the coefficients, but you also need to look at the variables as well, right? Because the GCF can be made up of both the coefficients and variables. When I look at the coefficients, the GCF I'm seeing is a common factor of 2, right? 8, 12, and 10 are all multiples of 2. When I look at the variable terms, I see an x cubed, I see an x squared, and I see an x. They all have one x in common. So I'm going to write the GCF as 2x, and then I'm going to put parentheses, because when you factor something, right, you need to write it as a multiply. So we have to figure out what you would have to multiply this 2x by to get back to what you started with. Now, because we started with 3 terms, we have to get back 3 terms, which is why we have 3 things in here that'll get left behind. So the first question we have to decide really is, what would you have to multiply 2x by to get 8x cubed? Well, I would need to multiply 2 times 4 to get back to 8, and since I have 1x already, I would need an x squared behind. Now, I like, after you think you have it factored, it's always a good idea to kind of in your head or even on paper ask yourself, does 2x times 4x squared give me back 8x cubed? And I can see here that it does. When I move on to the next one, clear this out. When I move back to the next term over here, I need to get back to 12x squared. Now, I can't forget about this minus sign here. Right? I need to deal with that too. So when I need to get this term, I know I'm going to have a minus here. In order to get back to 12, I'm going to have to multiply that 2 by 6. And since there's an x squared over here, and I already have 1x over here, I'm going to use 1x left behind. And again, I want to, in my head, check this to see that 2 times 6 is 12 and x times x is x squared. Now let's say you accidentally put the x squared here. Looking at the x squared up here, hopefully you'd recognize that x times x squared is x cubed, and then you would just simply go in and erase that and correct it. And that's part of the learning process. Sometimes you try to get close and then correct it to get it right. Now the last thing I have to focus on is this last term over here, the 10x. It's a positive 10x, so I'm going to say plus 5 to get back to the 10, and since I already have the 1x here and the 1x here, that's all I need. So this ends up being my final answer. Right. Clean some of this up so we can see the answer a little bit better. All right. And if you wanted to, you don't have to do this all the time, but I think sometimes it's a good idea to just check your answer. Right? 2x times 4x squared, that's 8x cubed. 2x times minus 6x, well, that's minus 12x squared. And then 2x plus 5, that's plus 10x. Okay? Now, there's all sorts of variations. There's all kinds of situations. It's possible that you might not have any GCF at all, in which case you could say it can't be factored, or you can use the word prime. It really doesn't matter. But the answer for all the factor problems is going to involve, at least in this section with GCFs, it's going to involve something outside the parentheses and then something inside the parentheses. You always have to have the whole part in the answer. Right? It's important that you practice a bunch of these, and feel free to get in touch with me if you have any questions.